The star of today's video is going to be this old antique sewer rotter. And I say antique because everything about it is made in an old school way, including how heavy duty it is. It is commercially made. Viking. I'm going to see if I can pull some information off that. But it's got a little foot here, so when you put it on the ground, she doesn't fall in. Dayton motor, which is available through Granger, if you're not aware. Simple belt drive. This one has the world's shortest cord and a switch. Well, what I know, and the end of it has broken off. There's like an inner core here of plastic, possibly to retrieve it or maybe just to help it not wind up. I'm not sure. But it is broken off, and the only bit it has is here. What I was starting to say about the switch is, one thing I noticed is it just sits there and hums. It doesn't really go. You would think it would be off or reverse, off, forward. It's 3 positions, but it doesn't do that. But if you spin this by hand, it will go in the direction you want it. So I think that's interesting. It says capacitor start. Well, I have a feeling in there is a capacitor that has gone bad. You can hear it click when you get it to speed. It's a similar motor that, like a bench grinder, when it gets up to speed, you hear that click. So anyway, don't know where this project's going to end up. But let's get to it and see if we can make some sense of what's going on here. All right, I got the microphone right down there. Now let me plug this in, leave that in the middle position, and see, it just hums. But if you hand start it, if you hand start it, it'll go, it's counterclockwise. And then you hear that click again. Coming again, the other way, and the motor goes. But what's interesting is, once running, nothing changes. You can't stop it. You have to unplug it, which these modern ones would have a air-operated switch. You'd mount a switch here out of box, and they would have a squishy air pedal. And I think they do that as a failsafe, so when you let off it doesn't keep going. Like if your arm was wrapped up or the rod was starting to wrap up. Let's get this up. If you got stuck on something, which is how this one got broken, that it would stop. You would be able to let off. And I think they do the air hose in a way that you wouldn't get shocked either, even if something shorted out, even though you should always be on the GFI circuit working with water. Some people don't, and I think they do the air switch also for that reason, even though you could still get shocked through the rod, I guess, if you were holding it, but with wet hands, of course. So you'd always should be GFI. But I wonder if this capacitor is just bad because, like, why wouldn't it make a difference where this switch was? Okay, now it's going clockwise. It started clockwise when I did that. Now let me go middle position. That time it started by itself. Just humming. Up position. So it does work. But you can't have it already started. Once you start it, it's going in that direction and not stopping. So it does work in both directions, but no off. Very interesting. We wouldn't do it that way today. So this way's counterclockwise. This way should be clockwise. Yeah. So it does run. But the middle position, why we would have power going anywhere there, like if I let that stop, just hums. Why would it give power anywhere? Well, I guess it doesn't matter. I've now figured out it can work by itself. The capacitor isn't bad. It's just something is wired a little differently than I would expect it to be on this reversible motor. Okay. That's good information. Okay, I was just looking at some stuff off camera a little bit there. So as I said, it's got some kind of core in here, which is interesting. And I could see the core probably used to stop right here, which is a connection. So maybe, what is it, about 2 feet from there to the bit end. And then they just welded that. Well, what I originally was thinking is if I was going to reuse this rod, I would just take that and weld it. I guess you don't really have to ever take it apart, but that is a factory connector. Looks like there's a rolled pin or more likely a Allen head screw there. But what I'm saying is if this is designed to retrieve a broken cable by pulling, it would have terminated here. I don't see it. If I look in the sunlight, if I look through the cables, the coils, I don't think I see it. No, actually, I do see it in there. But I thought I didn't see it all the way up. Yeah, see, it's not in there. I'm very close to the end. So that can't be for retrieving it. You know, I thought maybe the plastic would give you something to pull if the metal part snapped. But that can't be because I could see it. Here's where my hand is. That's where that connector is. It couldn't go through that connector. So it must end at this connector if that's the case. If it is tied in hard, well, here, I know how to tell. Why don't I just pull on it? No. There you go. There's a blunt end on it. No signs of that ever being crimped to something. And it would have stopped. There we go. Putting it here. It would have stopped just short of where the connector is. So apparently that is just to prevent it from kinking upon itself. Okay, that's good to know. Just for my own reference, what diameter is this? That's 3/4 inch cable. Okay. Just running through multiple scenarios out loud. So actually, if I only wanted to lose this much cable, originally I was going to take the stub and weld it all the way up here. But I could leave this all stock to the connector, cut it here now that I see I have a connector to weld to. Because I didn't want to weld the coils because I know it gets hardened and it'll probably just snap. But if you're welding like they did, right to, not coil to coil, but coil to that half connector there, that's how they did it. Maybe that would be a better fix if I'm not going with the new cable. I'm just still deciding a lot of things because this is not my machine. In the name of getting all the options, I've pulled all the cable out. I'm going to measure that. I'm going to see how much a new cable like that would be. And again, I found a connector here. And all you do is tie it in there at the end onto the frame so you don't lose the whole thing down there. This one's just got some greasable bearings in there. Okay, here's what I got for measurements. I got 6 foot for the leader that stays in the machine, about 90 feet of rod, and 2 foot to the end piece. So we're looking at like a 98 footer. So I guess they probably call that a 100-foot rodder. That's good to know. I got you zoomed in there. So that's a rolled pin, not a Allen screw, probably because they don't want it to come out. Now it's never come out, and I don't want it to ever come out. So I don't think I'm going to mess with that. Not saying that I couldn't get one back in there, but it looks like the weld is just, I'm going to clean it up a little bit. It's just from here to here, but I wonder if this piece has metal extending in here to get more grab on it, not relying just on that little piece of weld to turn, but that it's actually inside this hollow coil spring rod. Got you zoomed up in there stupid close. Yeah, it does look like there's a little piece of metal that goes inside the first couple coils there. But yeah, they just ground it flat, dead flat, and then just weld it about wide as my finger right there. I could do that. At this point, I'm wondering if that thing threads into the rod. It's only about an inch long in there, but it doesn't seem to be sliding off easily. Yep, she's threaded. Or at least that seems to be letting it loose. Yep, threaded on purpose. There you go. There you go. Get a good look at that. Just a couple of basic threads, but they're the exact size of the rod. That way, I guess the weld doesn't have to hold all that torque. So my goal is to make something that looks like that. And basically, it's an exact flat cut. So I got mine locked into this to hold it for me. And I'm just going to cut that. I assume that plastic core will just move out of the way as I try to get this. That tightens up quicker than I thought. Which way was I going? Ah, I just unscrewed it. Nice. Get you a close-up, show you how that turned out. So the left side, right here, I don't want to touch it because that spring's probably still hot, is bottomed out. Whoop, right where we want it. And that leaves us just enough room to weld. Got that all welded up. You see a couple grind marks there, just to get it from snagging on something as it spins. And we're good. Okay, we got a good working rod. Let's just give this, I assume this is a greasable bearing because there's grease all over here. Looks like maybe it comes out the top when it's done, being that there's some coming out the top. Let's give this some grease. It looks like this grease is both sides. This is sort of like a bicycle wheel. There's probably a bearing, and I think they both get greased from the one Zerk fitting on the front. And let me see if I can get this to fit in there. No, I'm a little long on this thing. And I don't think, no, I can't get it to fit in there down the tube. I'm going to have to go with a different grease gun. This one's got the lock and lube locker on there. And they don't have a 90-degree fitting there, so you can't get on it. Okay, plan B. Will this, hopefully being a little shorter maybe, get on there? Yes, it will. Gotta just get that on there a little farther. Oh, that's like gonna trap my hand almost. There it goes. There, we're seeing some grease come out over here. I'm gonna go a little further just to make sure we get all their old grease out. And hopefully it's getting all the way down to the bottom. Don't know if you can see that on film. It squished out a real lot that way. No need for all that excess because that's just going to get all over everywhere it shouldn't. You only need it inside, not outside. I like to use that Red-n-tacky grease. That stuff really stays put. Really good. Very nice. Yeah, that should roll beautiful. While we're lubricating things, I noticed this motor is of the old school variety and has these little oil cups. So we'll give those a little bit. Probably has the old sleeve type bearings. Have I got you here? Yep. And the wick keeps the bronze lubricated. Get a little more on the front end. Those front end bearings really take a beating. Good. Got you back out here. New day for me with the sewer router project. And what I decided to do, the direction I decided to go with this, I wasn't sure if that was so safe having that not to be able to shut off with the Deadman switch. I was going to wire an air switch in here. A new one would have a box with a switch in it with a little air hose and a plunger that you step on. That's just a Deadman switch. I assume they do that so you won't get shocked. You should always be in a GFI outlet anyway. So in order to get this machine safer than it is now, and for low cost to the person that owns it, I bought this. It's a foot activated switch, and you literally plug this end into your source, plug the machine in there, and it does the rest. So let's give this a shot. Okay. Put that in one way or the other. That way when you let off, oh, you can't see my foot. It actually shuts off. Now it rolls for a minute because I lubricated the heck out of those bearings the other day. Let's see if it goes the other way. Yep. Now when you step off it, the power kills. Much safer. And for the cost of that, which is about the cheapest switch you could find, link in the description, it increases the safety by a large margin because it actually has a way of shutting off now. And this is actually plastic. I didn't realize that, so you're not going to get shocked anyway. So all good to go. You can get those in metal. You can get those in premium ones. I bought the cheapest one possible just to get them back on the road. The other thing I did is order a new belt. And because of the small size of that pulley, this is a belt, or 4L, they call it, V-belt type. To go around a small diameter pulley, you really want an AX belt. They have cuts in them that allow them to go. They call it a cogged belt, but it's not a cogged pulley. It's just a regular sheave, I guess you call it, pulley sheave, whatever you call yours. They have little notches out of the back, the inside of them, and that allows it to go around a small diameter pulley and grab well. So I went ahead and I don't have that for the video, but imagine that with the new AX belt. So once that belt comes in, I'll put it on, and we'll call this one Wildwood Certified. Thanks for watching.